don't need to code anymore, AI will do it for you. Programming is dead now. You must be hearing all of this all over the internet. But here's the truth. Learning to code is still one of the most valuable skills you can have even in the age of AI. Let me explain why. First, AI tools like ChatGPT or GitHub or Copilot can help you write faster code, but they don't replace understanding. If you don't know what code means, how will you debug it when something breaks? AI can suggest, but you need to be the driver, not just a passenger. Second, coding teaches you problem solving and logical thinking. Even if AI writes some of the syntaxes, you are the one who needs to design the system and break down the problem. Even if AI writes some of the syntaxes, you are the one who needs to design the system, break down the problem, and make decisions about the architecture, and that skill can't be automated. Third, AI is built in top of the code. Every powerful AI model you see today was trained, deployed, and scaled by engineers who know programming. If you can understand the code, you can go beyond just using AI. You can create, customize, and innovate with it. So if you're wondering whether you should still learning programming in 2025, the answer is big yes. AI is a tool, but coding is the superpower that lets you control that tool. Want to become a software engineer but you don't know from where to start? I have been there too. When I first started learning coding nearly 15 years ago, I had exactly the same question. Frontend, backend, full stack or DevOps, I will guide you through it all. Before we begin, let me introduce myself. I am a software developer with nearly 15 years of experience building everything from web apps to the enterprise systems. And I'm here to share that whatever I have learned to help you grow in your tech career. Here's the truth about becoming a software engineer. If your skills are too general, getting hired in 2025 is tough. Knowing a little bit of Python, some JavaScript, and basic Git isn't enough. Employers want developers with depth knowledge, people who have mastered a focused path, not just who dabbled in everything. That's the difference between being a beginner and becoming a professional. So to be a software engineer, you obviously need to know how to code. You need to know how to write basic code and probably even more advanced code as the time goes. And you need to understand all of those core concepts that I'm sure you might have heard a lot of times. Functions, if statement, print statement, conditions, variable, all that stuff you need to know no matter which programming language you are going to end up learning. Next up, data structure and algorithm. Some people say you don't use them much at work, but here's the thing, they are the backbone of computer science. You might not be reversing linked list every day, but knowing how they work makes you write faster, smarter, and more efficient code. And that's what exactly separates a good engineer from the great ones. Next, you have got to learn Git. No matter what type of development you do, version control is non-negotiable. And Git is the industry standard. You should know how repository works, how to commit, how to push code, and how to collaborate with others. And guess what? It doesn't take too long to learn, but skipping it will hold you back in every single project you do. Learning to code is great, but learning coding best practices is what makes you a real engineer. Clean, readable, and maintainable code isn't just for you. It's for every teammate who works on that project after you. Following best practices save times, reduce bugs, and make you stand out as a professional developer. Once you have nailed all the core skills, it's time to choose your path. In this video, I will break down the 3 roadmaps, frontend, backend, and DevOps, so you exactly know where to go next. So let's begin exploring the front-end development. To become a front-end developer, it is essential to start by mastering 3 core technologies: HTML, CSS, and JavaScript. The important thing is that you need a solid grasp on all of the 3 before tackling any serious web development. Begin with the basics of HTML, learn about its elements, the importance of semantic structure, and how to use tags correctly. Next, shift your attention to CSS. While you don't need to become a master in CSS, however, it is important to understand the layout techniques, the fundamental of styling properties, and the essential portion of CSS. Lastly, put significant emphasis on learning JavaScript, as front-end development involves writing substantial amount of JavaScript, making it the most critical skill to build. Now, after gaining a solid understanding of HTML, CSS and JavaScript, the next step is to explore some front-end frameworks. To grow into a proficient front-end developer, you should become familiar with one of the three leading frameworks: React, Angular or Vue. Choose the one that aligns best with your learning style. Personally, I prefer Angular because I use it most often. There are plenty of debate online about which is the best. So if you are aiming for the most job opportunities, React or Angular are likely the way to go. After that, focus on learning all the ins and out of your chosen framework. An important concept to tackle next is state management, which plays a vital role as your application scales. While numerous libraries are available to assist with this, it's best to begin by learning the built-in state management options, such as React Context API, before you move to the widely used tools like Redux or NGRX. Now, it's time to explore more advanced concepts in web development. A key area to start with is responsive design, which mainly focus on ensuring your websites functions and displays content properly on wide range of screen sizes, from large screen desktop monitor to the compact mobile devices, as well as across various web browsers. This involves dynamically adapting the layout and elements to suit the best viewing environment. After that, it's important to concentrate on APIs, how to integrate them into your application. As a front-end developer, you will frequently rely on APIs to retrieve and send the data. Gaining a solid understanding of APIs also requires foundational knowledge of how the backend operates, and thus helping you understand your responsibilities when communicating with the backend systems. Let's move on to the TypeScript. It's essentially an enhanced version of JavaScript that introduces features like type annotation, static type checking, making it easier to catch mistakes during the development. You don't need to master every detail right away, but it's important to know that TypeScript has become a standard in front-end development, and you will likely to be expected to use it. And you know what? The upside of TypeScript? It's relatively easy to learn. In fact, you can grasp about 90% of what you will use in just an hour. Next is testing, an essential skill for every software developer. It is important to understand the distinction between unit testing, integration testing, and end-to-end or system testing. You should get comfortable with different testing frameworks, which can vary based on the type of front-end code you are working on. After that comes animation. While you don't need to be an expert, having a basic understanding such as how to use CSS animation media queries can help you add subtle effects that enhance your website appearance and create a more polished user experience. Next, it's a good idea to get familiar with Next.js. It's a framework that supports server-side rendering and offers powerful features for building modern web applications. You don't need to rebuild everything with it, but it's definitely worth learning as it's rapidly gaining popularity and is widely adopted by many companies in their tech stack. It's also important to understand that front-end development involves a wide range of tools and workflows which are designed to streamline coding and improve collaboration and boost overall productivity. Essential development tools like Webpack, Gulp, Yarn, NPM, which help you manage your dependencies and build processes. It's also helpful to have the basic understanding of DevOps, which is the process of deploying the application. While you don't need the deep expertise, understanding the concepts like CI/CD pipelines, automated testing, and popular deployment platforms such as Vercel or GitHub Actions can be very valuable. Lastly, it's important to get comfortable with browser developer tools. At some point, you will need to debug issues, analyze performances, and see how your application behaves directly in the browser where everything is ultimately displayed and executed. So let's start with the very basic question: what is backend software development? When you use your favorite app for ordering food, checking your bank balance, or streaming a movie, most of the magic happens behind the scenes. That hidden part is called backend. So the backend is the brain of any application. It handles the data storage, business logic, security, and communication with other systems. It's like kitchen in a restaurant. The front end is the waiter taking your order, but the back end is the chef preparing the meal. The first thing you need to do if you want to become a backend developer is identifying what language you want to primarily write code in. Now there is a lot of different options here. I'm going to give them to you, and you might just want to pick the one that you're most comfortable with. We're going to break the backend development in two major parts. First, languages and framework. Second, databases, security, DevOps, and cloud. So let's start with the core, the languages and the framework. First up, JavaScript, the most popular language in the world for web development. It's originally designed for the browsers, but JavaScript now runs on the server, all thanks to the Node.js. So why Node.js? Node.js is built on Google Chrome V8 engine, making it fast and efficient. It uses an event-driven, non-blocking IO model, which basically means it can handle thousands of simultaneous requests without breaking a sweat. So when to use Node.js? It's perfect for real-time apps like chat platform, multiplayer games, or APIs that needs to serve a huge number of users at once. Next, pair Node.js with Express.js, a minimal flexible framework that makes it easy to handle routes, middleware, and REST APIs. Express gives you a cleaner structure for your server-side code while still letting you customize freely. Let's talk about an example stack. Choose JavaScript-based frameworks like React, Vue, or Angular for your front-end and Node.js plus Express for your back-end. One language end-to-end, this means less context switching, faster development, and more job opportunities, since full-stack JavaScript developers are always in demand. Netflix, LinkedIn, Uber, PayPal, all high-traffic platforms rely on Node for speed and scalability. If you are a beginner starting with Node.js, Express is one of the fastest way to get your first backend project running. Next, Python, one of the easiest languages to learn but also incredibly powerful in production. I would divide learning Python in three parts: Django, Flask, and Fast API. Let's talk about Django. It's a full-featured framework with everything you need built in: authentication, admin dashboard, ORM for databases, and a structured project setup. It's great for large applications where consistency matters. Now, what is Flask? It's a lightweight and flexible. You start with the basics and add only what you need. It's ideal for microservices and small APIs. What is Fast API? It's asynchronous in nature, extremely fast, and designed for building APIs that can handle really high load. It integrates perfectly with the Python async feature and has automated documentation generation. Now the most important question: when to use Python for backends? If your application involves data science, AI, or machine learning, I would say Python is the easiest and fastest to integrate with mentioned domains. Next is Ruby on Rails. It's opinionated framework that emphasizes convention over configuration. So Rails basically lets you prototype and ship features quickly because it comes with sensibly defaults and pre-built solution for most common tasks. It's still popular for startups and MVPs, and it also powers companies like Shopify, GitHub, and Basecamp. So when to use Ruby on Rails? If speed to market matters more than fine-grained control, Rails is worth learning. Now let's talk about two enterprise giants: Java with Spring Boot and C# with ASP.NET Core. Java has always been go-to enterprises backend system for decades: banking, telecom, government portals, healthcare, you name it. Why? Because of its stability, performance, and massive ecosystem that progressed over the years. Spring Boot modernizes Java development. How? Well, it auto-configures project so you can start coding immediately. It comes with embedded server like Tomcat, so you don't need a separate deployments. It can integrate easily with security frameworks, databases, message systems, which makes it perfect for building REST APIs and microservices. Spring Boot also plays well with Spring Cloud, letting you build distributed system and handle service discovery, load balancing, and centralized configurations. So when to use Java? If you want job security, work in corporate or financial institution, or handle mission critical software, Java is still the king. Another enterprise giant is C# plus ASP.NET Core. If you are in a Microsoft environment, C# is your best bet. ASP.NET Core is fast, cross-platform, and great for enterprises web APIs, especially if your company uses Azure. It's also popular in ERP system, healthcare, and manufacturing. At the end, I can say both Java and C# ecosystem have strong tooling, robust security options, and long-term career prospects. So that's the languages and framework lineup. I would suggest you to pick one as your main specialization, but understand the basics of others so you can adapt well in the job market. When we build backend application, writing code is only half the job. The other half is making sure it works correctly, and that's where the testing comes in. Testing helps us catch bugs early, ensures feature works as expected, and keep our application stable even after new changes. In backend development, we often deal with different type of testing. So the first one is unit testing, which is testing individual functions or modules in isolation. Next is integration testing, which is about making sure different part of the system works together perfectly. And then end-to-end testing, which is simulation of the real user scenarios to check the entire flow. Depending on the programming language and framework you use, there are different tools. In Java, we commonly use JUnit for writing unit test and Cucumber for behavioral-driven testing. In C#, NUnit is a popular testing framework for checking the backend logic. In Node.js, you will often see Mocha or Jest. Jest is great for quick snapshot-based testing, while Mocha is highly flexible. In Python, the built-in unit test module handles most tests needed, and frameworks like PyTest make it even easier. The goal isn't just to test until it passes. It's to build automated test suites that run every time you deploy or update your backend, so you can catch issues before they can affect real users. Now let's talk about the other half aspect of the backend development, which are databases, security, DevOps, and cloud. In the world of software development, databases are where your application memory lives. Whenever you sign up for an app, post a photo, or make an online purchase, all that data needs to be stored somewhere safe, organized, and easily retrievable. And that's exactly what databases do. We mainly have two types of databases currently in market, SQL and NoSQL databases. So what are SQL databases? Famous SQL databases like Postgres or MySQL, which stores the data in a structured table with rows and columns, which are perfect for organized data and complex queries. And what are NoSQL databases? So famous NoSQL databases like MongoDB or Cassandra, which are more flexible and store data as documents or key value pairs, making them great for unstructured or rapidly changing data. Some application also uses Firebase, a cloud-hosted solution that provides real-time data syncing, especially for mobiles and web apps. A well-designed database doesn't just store information, it ensures the data is secure, consistent, and fast to access. It's the foundation that keeps your backend running smoothly all the time. Remember, without a good database strategy, even the best code cannot save a slow or unreliable application. In a software development, two words often come up when talking about the security: authentication and authorization. They sound similar, but they do very different jobs. Authentication is about who you are. So when you log in into an app using a username or password, or maybe a fingerprint or a Google account, that's called authentication. The system is simply verifying your identity, asking, are you really who you say you are? Authorization is about what you can do. So once the system knows who you are, it decides what resources you have access to. Can you read this file? Can you edit that record? View admin settings? That's authorization. In backend development, these are often implemented together. For example, JWT JSON Web Tokens are a common way to handle authentication in modern APIs, while role-based access control or permission systems manages authorizations. In modern software development, it's not enough just to write code. You also need to think about how that code gets deployed, maintained, and scaled. And that's where the DevOps comes in. So DevOps is a culture and set of practices that brings development and operations together. So software moves from your laptop to production smoothly and reliably. So let's break down the DevOps in 3 key parts. 1. Docker, which simply used for packaging your application. So Docker lets you put your entire application plus all its dependency inside a container. Think of it like a portable box that runs the same everywhere, your machine, a test server, or the cloud. Next is CI/CD pipeline, which is nothing but automating the process. CI/CD stands for continuous integration and continuous deployment. Continuous integration means every time you push code, it's automatically tested and merged. Continuous deployment means that once the test passes, your app can be automatically deployed to production or any environment. Tools like GitHub Actions, Jenkins, or GitLab CI helps automate this process, so developers spend less time on manual steps. Next is Kubernetes, which is about orchestrating the containers. So if Docker is about creating containers, Kubernetes is about managing a lot of containers. It helps you deploy, scale, and monitor application across multiple machines. Kubernetes automatically restarts failed container, balance traffic, and making scaling easy. So no matter you are running 3 containers or 3000 containers. Last but not the least, let's talk about cloud. So in today's software world, most applications don't live on a single physical server anymore. Now they live in the cloud. A cloud provider gives you access to server, databases, storage, and services over the internet, so you can build and run applications without worrying about the physical hardware. The 3 big major players in the market are AWS, Azure, and Google Cloud Platform. So let's start with AWS, which stands for Amazon Web Services. AWS is the largest and most widely used cloud platform. It also offers services like EC2 for running server, S3 for storage, RDS for managed databases. AWS is known for its flexibility and massive ecosystem. You can pretty much build anything on it. Next is Microsoft Azure. Azure is deeply integrated with Microsoft products, making it a great choice for companies who are already using Windows Server, Active Directory, or .NET application. Azure also has strong offering in AI, analytics, and DevOps tools. Next on the list is Google Cloud Platform, or simply GCP. So GCP is Google answers to the cloud computing, known for its data analytics, machine learning, Kubernetes expertise. Services like BigQuery and Cloud Run are the favorites among data-heavy and container-based projects. Now let's discuss why cloud knowledge matters for backend developers. You can scale your application up or down instantly. You only pay for what you use. You get built-in tools for security and backups and monitoring. In short, learning at least one major cloud provider is essential for backend developers in 2025. Whether it's AWS, Azure, or GCP, cloud skills makes you not just a coder but a complete solution builder. Alright guys, as we saw, the platforms are so different and it's very difficult to give a step-by-step roadmap because it really depends upon what exactly you want to do. And that's wrap up the complete roadmap to becoming a software developer. Now I would like to hear from you, which path are you planning to take, front-end, back-end, or DevOps? Drop your thoughts in the comments below and let's start a conversation. And if you find this video helpful, please give it a thumbs up and share it with a friend who's also learning to code. And also don't forget to subscribe for more deep dives into tech and career growth. Your feedback means a lot. Thanks for watching and I will see you in the next one.